Good morning.
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 Morning.
Доброго дня.
Good morning.
Інеса Миколаївна, вас не чути. У вас виключений мікрофон.
Доброго дня, Ілляна Тарасівна. Рада вас бачити.
Доброго дня, Олена Володимирівна. Навзаєм раді бачити.
Успіхів нам
Так.
у всьому.
Це правда.
І перемоги нам всім. Бо дуже цього потребуємо.
I'm sorry. Good morning. We continue our conference and I'd like to welcome everyone. I invite all participants and speakers to start the third day of our work. Once again, I would like to thank Armed Forces of Ukraine for the opportunity to move science forward even in these difficult times. No one can change the past, but the decisions we make today determine what our future will be like. This day is dedicated to practical trainings where our speakers will share their in-depth research in the field of energy projects and markets. Speakers and training topics will be presented by moderator Vladimir Landel. After each speaker's speech, you will have the opportunity to ask questions. Welcome, Vladimir.
Good morning and welcome all participants on the third day of the conference. I would like to give floor to Mr. Kilic Zeki, Foreign Affairs Manager and YTLS Energy Engineering Limited from Turkey, on the topic Stop Working on Hydrocarbon Energy Projects. Welcome, Mr. Kilic Zeki.
Have a nice day to all participants. It will be a great honor for me to give the information about our company and to these valuable participants. And really, right now in the world, we need sustainable energy, not to be slave of someone who is right now using this fossil energy to every country. And this is the main of our subject. And stop working on the carbohydrate energy project. We have to search sustainable energy from the sources of the world. We have enough this. Thank you. And let me continue my speech, please, regarding to this. This is my presentation, and it will be introduced to you regarding to our company and from the past of our experience, and later, and I will say something about the hydrocarbon energy, and then the wind energy, the solar energy, and also tidal energy. It is the same of wind energy. Do you see me in this camera and presentation also?
Oh, we can see your presentation.
Okay, thank you so much. ITL Engineering Company profile, trader register number 74917797. And about us, ITL Energy and Engineering has been acting in Middle East as well in Middle Asia countries more than 30 years in hydrocarbon energy sectors. We are providing turnkey service for the project, including feasibility studies, design, manufacture, installation, commissioning of the staff, training for the oil and gas facilities, as well as the industrial installation related to fluid management. Certification and working standards. As you know, before getting to any tender, you have to have certificates. And that's why you have to train your team and you have to have your equipment to get the tender to survive in the market. So you have to be first ISO international standard. This is quality management. We have this certificate. And also environment management system. And the occupational health and safety. This is the most important one also. And Turkish Army, this is for NATO. In order to get the tender and the project from the NATO, we have to have this certificate also. And other United States construction registry, in order to have tender from the United States, you have to also this certificate. And the United Nations also has to have this certificate also. And we are working in the international accepted standard like IPI, this American Petroleum Institute, and American Society of Mechanical Engineering, American Welding Society, American Water Works Association, National Fire Protection Association, European norms, and International Organization for Standardization and Turkish standard also. We are working with this standard. And when you show this standard that you are working, it is very nice to get the chance to get the tenders. Our activities in general engineering, design, procurement, construction, installation, commissioning, and operation, as well as the maintenance and modernization of the oil terminals, chemical bulk liquid and dry storage depots, marine and land loading or unloading facilities, and horizontal atmospheric storage tank at any capacity, oil, LNG, LPG, chemicals and water pipelines, fuel filtration, additive systems, retail stations, firefighting systems, general industrial installations, and turnkey bases constitute our scope of supplying. In engineering operation consulting, feasibility studies, terminal planning, and statutory affairs, preparation of tender document, and project management, engineering, operation cost studies, procurement, training of the terminal operation after finalizing the project. Providing services, we are provide assistance all by covering base services and for the equipment system that will be used for pump compressor, power generators, product metering system, tank level gauge system, injection filtration systems, terminal automation systems, hoses for industrial application. I know most of you knows about this, but I wanted to refresh your memory about that. So excuse me for also this. So how to conduct to our activities? And design, we have all our design engineers. And procurement also we have this well-educated, experienced people to procure the material for the contract that we have. Distributors and dealership, installation and erection with our personnel. Manufacturing, we can manufacture everything, but sometimes when we are not enough for the time period, you can give the contract also. Inspection control test also. We have our inspection test, but sometimes you can go to the contract also. Painting, we have well-educated, well-trained people in our facility, and if you're not enough for the contract, you can hire some contractor for yourself, this subcontractors. Packing and loading the same. Transporting, we have our own transporting system, transporting facilities, commissioning, and after sale, service, and maintenance. And as you see in the slide, this is design of fuel terminal, and this is only design. And before any getting any project, you have to design what you are going to do with your qualified engineers. And as you see, the ship is coming to the berth, and this is discharging. It is fuel whatever and to these tanks, and there is also one exit for track and to take the diesel or fuel to distribute to the required places. And as you see, this is another field design which was made by our qualified engineers. HSA, health, safety, and environment, is the most important subject in tenders in contract when you are there. Staff and technical people must be equipped with necessary safety protection equipment before entering to the working zone. HSA engineer must inspect every people in the morning before starting to the job. In lieu of any technical person will lost the time for the contractor. It is very, very important. Let's say you got one tender and one tender, then you are producing, and you have also time limit to finish the contractor. And when you lost someone, also it will lose the time, it will lose everything. Then you will also may lose the tender also. And this is another reason from our personnel. They got their safety equipment before going to job with this HSN engineer. Base installation of the tank. The location where will the reservoir be installed must be calculated per environment and geological conditions like earthquake, wind factor, fluid, temperature effect, grain, and historical zone places. It is very important before doing something, and we have to calculate, we have to take in consideration. The metal thickness, sand, cement, and isolation must be selected and for foundation of the tank. As you see in this slide, there is a foundation of the storage tank, and the cement right now is filling to the base. And this is finished. This cement filled this base, and this is installation of the tank. As you see, there's erected shells and about 50 shells, and right now they are going to put the column for the top shells. And this is, as you see, this is another installation of the tank, and right now they are going to put the column, center column for the top. And this is erection of the storage tank. This is finished one before the painting, And after this is another manufacturing from the workshop, and the erection of the storage tanks in Iraq. This is you seen. This is also I have told you we got so many tenders in the Middle Asia, like Pakistan and Turkmenistan and Iraq and Georgia. We have finalized so many serious projects. Now this is sandblasting before painting. This is very important operation before the painting. After the sandblasting, there is another operation to check the surface profile and salt test before the painting. This is very important, this is the sandblasting, just like a coating. Just like a coating, it is restricted all this bacteria from the surface before the painting. This is another painting, sandblasting operation in this column, as you see. And this completed fuel storage tank part. This is from our company. And another completed fuel terminal. As I have shown you from the beginning, from this one, this design. The advantages of the petroleum. This is right now that we are the slave for someone. Right now there are so many advantages. It is not acceptable. Petroleum provides with us a stable source for multiple industry. Humanity has embraced to use this product for more than 6,000 years. We use petroleum to make renewable energy even products. Over 100 liters of petroleum are necessary to create a single photovoltaic panel that collects sunlight for energy. It is cheap to obtain. The technologies that we use right now to harvest hydrocarbons from the ground make it an affordable commodity. Millions of people around the world have jobs because of the petroleum. Petroleum transportation is better than other fuel resources. We can haul millions of gallons of petroleum around the world without suffering and significant energy loss unless any spilling occurs. There are potential medical applications for petroleum. Petroleum was staple in ancient humanity medicine. This advantage still exists today. It works prevent peeling and chipping while managing specific conditions such as eczema. And these advantages of petroleum right now, this is also very important subject. In the infrastructure of the petroleum industry requires continuous maintenance. This is 1 year later you have to maintain your refinery and other facility that you are transporting it. Petroleum is significant contributor to greenhouse gas emissions. This is another disadvantages for surrounding and green surrounding laws. Exposure to petroleum is toxic for most life on our planet. The wealth that petroleum brings is fleeting. Hydrocarbons change the composition of the ocean water. If the petroleum comes into the contact with the sea life, then that almost always occurs. The same reason with the atmosphere becomes more acidity as it happens in the water. Disadvantages of petroleum. Petroleum is a source that nation go to the war. Right now that we are having the same in Ukraine, the beautiful country Ukraine. And the Ukraine does not deserve this. And really, the other countries right now is becoming slave of the petroleum. That's why I have selected that stop working on hydrocarbon energy. Petroleum is a resource that can make individual families and nations wealthy and overnight. Some may see this issue and advantages because it has the power to improve one's way of life, but it is a product that also inspires conflicts when one group has excess hydrocarbons and other doesn't have. Then that relationship can create trade wars, conflict, or outright battles. The number of governments that have risen and fallen because of this their desire to obtain this refuel is countless. Conclusion. Unfortunately, we need hydrocarbons in general that we are almost solely dependent on the products, even renewable requirement this fossil fuel to create usable energy. Some countries have already discovered that there is an urgent need to begin this diversification. The rest of the world will catch up soon. Stop and working Stop and working on hydrocarbon energy. For your information, I got this information from while searching the sustainable energy except the petroleum. I have found this article in the internet. I would like to share with you, and this may be a cause of the war right now in Ukraine. And for your information, 4 trillion cubic meter of natural gas deposit was found in Yuzhov gas field, which stretches across the Donetsk and Kharkiv regions of Ukraine, exactly where fierce fighting is taking place right now. The market value of Yuzhov gas deposit at the moment at the price is 1.4 US dollar. On the exchange, the Netherlands per 1,000 cubic meter of gases, 5.6 trillion US dollar. It will be recalled that Ukraine gross national product before war was 200 billion, which is the almost 30 times less than the market value of use of field gas. In 2012, the British Dutch company Shell won an international tender for development of this field, promising to invest $3.4 billion in development. In 2014, Shell was unable to begin to development of the field. The reason, the beginning of the hostility in the Donbass and in 2015, it was forced to withdraw from the agreement with Ukraine on development of the field. $5.6 trillion is huge money. For example, Russian annual export revenue from the energy exports about is 40 billion dollars. This almost 30 times less than the market value of from our use of field. Think about this $5.6 trillion deposit. And this is the main reason of the war. This is the main reason, not about the independent or the people who is living in this region. Please. Geopolitics is also money, big money here. Therefore, the Russian authoritarian narrative of selling the Russian Donbass along with 5.6 trillion dollar looks more than a screen. And you can see this is the link. You can also take the link from the internet. Thank you so much. We are right now in process of searching friendly energy for our company. Our company is getting necessary certification for wind energy, solar energy, wave, and tidal energy. The use of wind energy by some countries, Turkey, it is an example, this is my country. Wind power generates about 30% of Turkey electricity, mainly in the West, Aegean, and Marmara regions, and is gradually becoming a larger share of renewable energy in the country. As 2022, Turkey has 11 gigawatts of the wind turbines. The, the Energy Ministry plans to have another 10 gigawatts installed in 2023. But the International Energy Agency says that's not enough, and there is a techno-economic potential for the much more. Turkish wind energy sector attracted $12.3 billion over the past 11 years, according to Turkish Wind Energy Association. And this is some wind panel, wind in the Marmara region, Aegean region. Greece also is right now interested in much because also they don't have this petroleum to get the enough energy, and right now they are also working on this friendly energy. And Greek's renewable energy is dominated by the wind energy. Wind energy is the fastest growing renewable energy source. The total wind energy installed capacity accounts for share of about 37.9% of the total country's renewable energy. It is very nice, amount. 37.9 right now they are getting their energy from the wind. As per the Hellenic Scientific Association of Wind Energy Statistics 2002, onshore wind energy reached 451 megawatt of installed capacity in 2021. The onshore wind registered is 82% growth. You know Iran very well. Iran has so much, let's say, petroleum right now in all country, and also they are exporting from their country to almost all over the world. But I'm not sure that because of the sanctions, some of them does not achieve their goals right now. But according to this event, they are working on the wind energy right now. The energy system of Iran relies on primarily fossil fuels. However, the country has made steps to decrease its dependency on fossil fuels by investing in wind power. With the help from said industry group, Iranian manufacturing company, and investing as well as sources from Indian Solzian Energy and German Siemens wind turbines companies, Iran has been able to build a strong and stable wind sector. In 2004, Iran generated only 25 megawatts from the wind power, 32 megawatts in 2005, and the 45 megawatts in 2006, and is going increasing. This was a result of the production of the larger wind farms in more coastal land wind areas of the Iran, such as Manjil, Jilan province, and Binalaut, Razal, Khorasan province. These are very good for getting the wind, and they have investigated, they put their wind panel in these regions. Wind energy in Europe in 2021 statistic and the output. electricity generated from the European Union total 384.9 terawatt hours in 2021. This was decrease of about 3.2% in comparison to the previous year. Among our European member states, Germany proceed the most electricity from the wind power, generating nearly 114 terawatt hours that same year. The number of the wind energy related jobs worldwide amounted to 1.25 billion in 2020, a slight increasing from the previous year, between 2009 and 2016, wind energy jobs increasing steadily. This is very nice also for workmanship for the companies to get the job, to get the tender. This is another income for the people. But there has been a little growth since then. 81% of new wind installation in Europe last year were onshore wind. Sweden, Germany, and Turkey, again, Turkey is a part of Europe, and built the most onshore wind. The United Kingdom had the highest total new wind installation. Because they account for the most of new offshore wind installation, Europe now has 236 gigawatt wind capacity. We expect Europe to install 116 gigawatt of new wind farms over the period from 2022 to 2026. Three-quarters of this new capacity additional will be onshore wind. We expect the European Union 27 to build on average 18 gigawatt of new wind farms between 2022 to 2026. They need to build 32 gigawatt a year in order to meet the European Union new 40% renewable energy. This is the target. That's why they do not want to be dependent on the fossil energy. All these countries right now is working hard to not to be slave more for these hydrocarbon energies. This is sample of horizontal axis of wind turbine. As you see, these are rotor blades and the generator inside. And you know almost all of you, but I just wanted to refresh your memory about this. And this is for the axis, this is turbine working principle. Wind energy in Europe in 2022 statistic. As you see here, in 2021, new wind installation in Europe amounted to just 17.5 gigawatt, and the onshore also 14 gigawatt, and the offshore 3.4. As permit things and the bottleneck and the global supply chain issues continue to delay to the commissioning of the new wind farms, while 2021 stands as a record year for installation, surpassing the 17.1 gigawatt figures you have seen in this. And another statistic. Wind energy in Europe, because this statistic continues, Germany will be Europe's largest wind market thanks to the strong expected performance of its onshore market. Over the next 5 years, 19.7 gigawatt, and rising offshore installation 5.4 gigawatt. Other markets with the significant new installation over 2022 to 2026 will be the United Kingdom 15 gigawatt total, France 12, Spain 10, and Sweden 7. Solar power in 2021, the world's adopting renewable energy and on prediction on presented peace and solar power in the energy source leading the way, despite 4.5% fall in global energy demand on 2020. Renewable energy technologies showed promising progress with their growth. Renewables was strong across the board. Solar power led from the front with 127 gigawatts installed in 2020. It is the largest ever annual capacity expansion. The solar power leaderboard, as you see here, China is the first as usual, because of the population, they need so much petroleum, but right now they are working on the solar power. Then United States is the second, Japan is the third, Germany, then as it is, according to their economy, and right now they are the same in the same fourth. And this is also there is Turkey here and Ukraine at the bottom, but Ukraine also is using the sun energy. This is must be. This is must be because Ukraine does not have fuel, right? That does not have fossil energy much. They have to work on. We have to support them. We have on solar energy and wind energy, and it has to be not to display. We have to work. Wave energy. This is another resources along the European Atlantic coast. Most renewable energy already produced from hydraulic, wind, and solar power. In contrast, marine energy represents a teeny proportion of the current energy production yet. The Atlantic coast of Europe has one of the most important marine renewable energy resources in the world in terms of tidal range. This is tidal energy, it is just like a wind but under the water. Range such as in the Severn in Austria and the United Kingdom, or Saint Michel Bay, France, tidal stream such as in the Pentland Fort, United Kingdom, or near Alderney Island, United Kingdom, France, and Wales. Wave energy from the 5 European countries. France is the top that they are getting the energy from the wave. Ireland is the second, Portugal, Spain, and United Kingdom is the fifth. And these are the capacity according to the years and targets. And they install it from 2024, 2025, and 2020, which are they getting this capacity, the percentage capacity, and this megawatt and gigawatt. Wave energy from 5 European countries. Targets of renewable energy source as the percentage of the gross final consumption and marine energy distribution installed capacity as gross electricity generation for the 5 Atlantic European countries in 2021 and 2015. The production of the energy from these resources, the European Union Renewable Energy Directively has set a binding target to all members stated of providing 20% of energy supply with the renewable energy by 2021, 2020, and at least 27% by 2030. And these are the map of wave energy, which is in Europe. Estimated annually mean power distribution. These are the the regions with which wind is blowing and to get the energy, as you see here also, Atlantic Europe generally. And wave energy from the 5 countries, European countries, as you see, this is also coastal of Atlantic Ocean. And tidal energy from Scotland. This is tidal energy, and most of you know, but I wanted to refresh it again. And just like wind energy, this is under the water, and it is work with the tidal, and while with the running of the water under the water, under the surface, and just this there propeller also. When the tidal is coming and it is working with the acting of the running of the water under the surface. And tidal energy from Scotland. Tidal energy waves and wave energy uses the ocean currents or waves to generate electricity. A tidal generator uses the motion of the ocean tides to turn the turbines that generate electricity similar to the wind generation. There are many reasons why renewable energy is becoming crucial, given that we live on a planet with limited natural resources. There is only a set amount of fossil fuels that we could use cleanly. The most powerful tidal turbine globally is the Orbital Marine Power 02 in Scotland. It has started export electricity power to the national grid, even for the tidal energy under the water. Wave and tidal energy, these are some views. This point absorber, wave over tapping. This is working under, and with the motion, it is creates the power, and this is point absorber over tapping, and tidal energy and visuals again. This is for wave over the surface, like that. This is main, and these are oscillating power, and this is also like that. Wave energy and tidal energy visuals again, and this is main, maybe 3D visuals. Wave and tidal energy visuals like that. This is also with the wave, it is coming and pushing the water, and coming again, it is working this moving the turbines to create the electricity, as you see here. And this is wave tidal energy visuals, the same. Oscillating wave surge converter. Slava Ukraine, thanks for your attention. And I would like to answer if you have any question about the slides that I have presented you.
Thank you, Mr. Kilic. Please submit your questions.
Can I ask one question?
Yes,
thank you
please.
for your presentation. Please, could you clarify, does your company have any experience of cooperation with Ukrainian companies, or maybe you have some planning for this cooperation in the future?
We have right now with the University of Oil and Gas Internship right now agreement with the university. If there is some project, also they will tell us to involve this project. In the future, we have also agreement right now with the University of Ukraine and Oil and Gas University. We have internship agreement.
Okay, thank you.
If any project will be given to us, also we will appreciate, and it will be a pleasure for us to involve the family. Thank you.
Thank you. Any more questions? Thank you, Mr. Kilic, for your presentation and very scientific and knowledgeable approach to that issue. Thank you again. Now I would like to give floor to our next speaker, Mr. Andriy Belinsky, data scientist at Kryvyi Rih State Pedagogical University from Ukraine, on the topic, the state of reversibility in energy-related markets and their identification. Welcome, Mr. Andriy Belinsky.
Yeah, thank you. So can you see my screen?
Yes.
Okay. Good morning, everyone, dear listeners. My name is Andriy Belinsky, and today I would like to present you our study, which is titled as The States of Reversibility in the Energy-Related Markets and Their Identification. So the plan of my presentation is the following. First of all, I would like to present you a motivation of our research. Then I would like to introduce measures of complexity. What is it? The classification. So that's exact measures of complexity which will be used to identify states of irreversibility in the energy markets. So then I would like to present you a short description of sliding window algorithm, which will be used to calculate these measures across time. This block of introduction also includes types of data that are used in our calculations. And also I would like to give you the definition of reversibility and how to measure it with the distance measures from information theory. And after it, I would like to describe such measures which are related to graph theory. There is two types of graphs, such as horizontal visibility graph and natural visibility graph. And related to them measures, related to them indicators such as snow degree and local clustering coefficient. And after it, I would try to explain you the sense of permutation-based approach and also Poincaré-based measures. And after it, I will give you practical usage of how to use such development environment as Jupyter Notebook for the corresponding calculations. And after it, we'll make some conclusions from all the mentioned approaches and all the mentioned calculations. So, amid Russia's invasion of Ukraine, the inflation-adjusted price of oil reached a 7-year high. And definitely Russia is one of the world's largest producers of crude oil, and many countries have announced a ban for Russian oil imports amid the war. This has led to supply uncertainties and therefore rising prices. A large portion of the world's oil is located in regions that are prone to political conflicts, and political events can disrupt the actual or perceived supply of oil and drive prices upwards. On the other hand, an economic downturn reduces energy demand and can depress prices. Investors' interest in oil as an alternative investment, it has risen in recent years. So given the high volatility in historical oil prices, investors may want to consider their comfort with this level of risk. Of course, an investor's sustainability goals may also be a factor when choosing whether to invest in oil. However, oil also presents opportunities. It has had low to negative correlation with US bonds in recent years, and it may help investors diversify their portfolios. Not only that, it may help investors manage rising interest rates. And economic recovery typically leads to rising interest rates, but also more energy demand. Oil prices have historically climbed during these periods. So definitely, as you can see, energy-related markets of oil and additionally gas are presented to be highly dependent on geopolitical events and interests of investors and traders. and the activity leads to self-organization of the corresponding markets, and the sentiments are reflected in the dynamics of the prices of the respective goods. So here I would like to present indicators or indicators precursors on the basis of complex systems theory. These indicators have to be an alternative to classical indicators such as moving average or Bollinger Bands, or other indicators, which very many. So these indicators have to be better alternative comparing to classical ones. I would like to show you how they work for three indices of energy-related market. So I would like to present you how they work on the example of West Texas Intermediate Crude Oil, or how it's shortly called WTI, for the period from 2nd January 1986 to 13 June 2022. Also, I would like to present you how they work on the example of Euro Brent from the 20 May 1987 to 13 June 2022 also. And the last one is Henry Hub natural gas. Spot prices from 7th January 1997 to 14 June 2022. So, in general, the paradigm of complex systems includes different approaches for studying complex systems phenomena such as oil or gas markets. As you can see, it includes such terms as nonlinear dynamics, game theory, collective behavior, networks, evolution, adaptation, systems theory, pattern formation. And all these terms also include different tasks, different terms such as chaos, stability analysis, phase space. If to speak about systems theory, probably the most known term here is cybernetics, information theory, and entropy. If to speak about networks, the most known here is scale-free networks, social network analysis, small world networks, and definitely in general graph theory. If to speak about evolution or adaptation, we know artificial neural networks that are known almost everywhere. We can speak about artificial intelligence in general, about machine learning, deep learning, about genetic algorithms. So as you can see, definitely complex system theory have very extensive it's very extensive paradigm. It has a lot of instruments for studying complex systems and for constructing indicators on the basis of this theory. If to speak about measures of complexity, measures of derived from complex system theory, it includes very many approaches. I've mentioned only a few of them. If to speak about information theory, that's Van-Zip complexity, different types of entropy, informational entropy such as Shannon entropy, approximate entropy, sample, fuzzy, permutation, and so on entropies. Also, we can speak about self-repeated processes, very detailed or very smooth, and we can study such self-repeated processes using multifractal fluctuation analysis, multifractal detrended cross-correlation analysis. Probably the most known for you is rescaled range analysis that gives us Hurst exponent. We can use the detrended fluctuation analysis for deriving like generalized Hurst exponent. Also, if you want to study chaotic phenomena, you can use such measures as largest Lyapunov exponents, spectrum of Lyapunov exponents. So if you want to find like bifurcation points in your system, how fast system converge or diverge, how periodic it's presented to be, how chaotic, you definitely would like to use exactly these measures of chaos. Also, if you want to study repeated patterns, if you study the process of liminarity, of some unchangeable processes or very changeable, you would like to use probably a recurrence plots, cross recurrence plots, joint recurrence plots for studying several systems and the cross repeated dynamics. And on the basis of recurrence plots, we have recurrence quantification analysis, which gives us different interesting indicators for studying how repeated is expected to be studied phenomena. And recurrence quantification analysis includes such measures as recurrence rate, determinism, line max, also entropy, liminarity, and so on. We also can speak about measures based on complex networks. So here I will present you a horizontal graph, horizontal visibility graph, natural visibility graph, but also we can use recurrence networks, multiplex networks, and on that basis we can quantify such measures as clustering coefficient, or degree, or centrality, or betweenness, or algebraic connectivity, and so on. So very many measures for studying complex networks. We also have some instruments from quantum theory. One of them is random matrix theory, which is very suitable for risk diversification, for managing your portfolio, but also studying correlation between different systems. So we can derive very useful indicators on its basis. So as I mentioned, today I will concentrate my attention on exactly irreversibility measures. I will present irreversibility measures based on Poincare diagrams such as Portas index, Costas index, Gusik's index, etc. Also, I would like to present you permutation-based irreversibility measures and graph-based irreversibility measures. But I would like to mention that irreversibility is an extensive topic, and nowadays it includes different indicators such as multi-scale time irreversibility index or multi-scale multifractal time irreversibility index. So for studying, for calculating corresponding measures of complexity, we need to measure how system exactly changes across time, how predictable is presented to be system across time. In general, when we use indicators that I mentioned previously, we calculate them for the whole time series. So we present our oil time series, gas time series as an array of points. And for this array of points, we need to calculate how changes it across time from 1986 to 2022. This can be done with the usage of sliding window algorithm. The idea here is the following. Suppose we have such array of points, such time series, and you would like to measure how it changes, how predictable is presented to be this time series. For my purpose, to determine how predictable, how complex is presented to be, I can choose subseries of predefined length, 5 days. And I predefine time step, which is 1 here. So for my purpose, I select this subseries and I calculate corresponding measure of complexity, any measure of complexity, permutation-based, graph-based, Poincare-based measures, and so on. And my results I save to some probably txt file or to some array. Then I shift this subseries by 1 time step, by 1 day. And then I repeat my calculations. And after I repeated my calculation for this particular subseries, I again save my results. So I add another result to my txt file or to my array. Then I again shift my window. I again repeat my calculations, again save my results to an array or to txt file. And this process I repeat until my time series will be ended. So this gives me an opportunity to measure how system changes across time. So this algorithm will be used exactly for studying how irreversibility changes across time, how irreversible are presented to be crash phenomena in energy-related markets. But the question is how to construct, how to measure the complexity, how to measure irreversibility, which data type to use for our calculations. Because we have different variants, as you can see. We can use initial time series to measure irreversibility or symmetry. We can difference our series just by subtracting from current value, previous value. We can calculate returns of our series. We can standardize our returns by subtracting mean of our returns and divide by standard deviation. We also can present our series in terms of volatility. So volatility is like absolute value of our returns, of our usual returns or standardized returns, and we can standardize initial time series. So from the current value, we can subtract mean and divide it by standard deviation. And some of them represents a symmetry or reversibility in better way, some of them in not very good way. But during our empirical results presented that the best here is presented to be initial time series and standardized returns. Moreover, for graph-based measures, we would like to use exactly initial time series. So initial time series for graph-based measures is presented to be much more stable. And for permutation-based and Poincare-based measures, we would like to use exactly standardized returns in this case. So a little bit about the notion of irreversibility. What is called irreversibility in our case? When we deal with some process X, we call it statistically irreversible, time irreversible. If for every data point, for every series, like x1, x2, and so on, xn, and for its reversed version. So they call it reversible if this version in forward time and in the backward time are presented to be the same. The same is presented to be joint probability distributions of corresponding time series. Also, we can say that for irreversible process, we can find function f that could be applied to find some characteristics that differ in forward and backward versions. So our time series is called irreversible if these characteristics in forward time and backward time are presented to be asymmetric, are presented to be different. This function, as an example, can be your permutation patterns. This can be, like I said, Poincare-based measures, or this can be graph-based measures, so degree, local clustering coefficient, betweenness, and so on. And that gives us an idea that we are not limited with the function of f. Function of f can represent different statistical characteristics that can differ in forward and backward versions. If we speak about reversible processes, we include like white noise, we speak about linearly correlated Gaussian processes, and when we speak about reversible processes, we speak about chaos, we speak about nonlinearity, and in general, we speak about processes with memory, multi-fractal characteristics, etc. And the last one, which I would like to mention, is that when we speak about reversibility for financial systems, exactly crisis events can be associated with corresponding irreversibility. So our crisis events are presented to be chaotic, presented to be multifractal, they are non-Gaussian in most cases. So that's why these processes can be irreversible in our case. So when we get some quantities in forward and backward versions, the distribution may differ. So we can have like P of X that represents a forward version. We can have like Q of X that represents the backward version, and these distributions can be presented to be asymmetric. When we found probability density function, we want to measure how these quantities differ. And this can be done with the usage of information theory, exactly with Kullback-Leibler divergence and Jensen-Shannon distance. I would like to mention that in our study we used exactly this Jensen-Shannon distance, but probably later I will present you how we will look results with the usage of Kullback-Leibler divergence in our case. So first of all, I would like to start with graph-based measures. The first type of graph that I would like to present here is called horizontal visibility graph. And the idea here is following. So suppose you construct a graph of a particular time series. In our case, that is oil or gas prices. So you have your prices as vertices, in this case, that correspond to a particular graph. But in graph, we need to connect corresponding vertices. We need to have edges in our graph. In the case of horizontal visibility graph, if you can connect vertices like I and j with corresponding horizontal line, exactly horizontal line, and if there is no obstacles in front of this horizontal line, then your vertices are presented to be connected. And here you can see more formal condition for which we can where we can connect corresponding I and j vertices. So again, as you can see, in the case of horizontal visibility graph, we need to connect our vertices with exactly horizontal edge. And if there is no obstacles, if we can do it freely, then this vertex and this one are presented to be connected in our case. And you can see the result of horizontal visibility. You can see visibility connections for exactly West Texas Intermediate. So as you can see, this one in this one period of time are presented to be connected in our case. But the highest period of time, like here, is not presented to be connected because we just cannot put a horizontal line between like this vertex and this vertex. So exactly this period of time, as you can see, is presented to be mostly disconnected in our case. And so here you can see like graph representation of corresponding graph. Definitely you can see that this graph is presented to be mostly uniformly distributed. And the degree of corresponding graph is presented to be very little, only 10 vertices for a particular a particular vertex, in our case. So you can see results for Brent crude oil, almost the same result. In our case, probably there are more connections comparing to WTI, but actually almost the same picture in our case. And in its graph representation, you can see that definitely much more connections between corresponding vertices, a little bit higher degree, but it's also mostly uniformly distributed. And visibility graph, horizontal visibility graph for corresponding Henry Hub natural gas. As you can see, these vertices are presented to be connected. These vertices are presented to be connected. These one are presented to be connected. So definitely for a given period of time, we can see much more horizontal lines comparing to previous indices. And here you can see its graph representation. But as you can see, graph representation of this period of time of natural gas is also presented to be mostly uniformly distributed in our case. In the case of natural visibility graph, our edge does not have to be horizontal, as you can see. So it can have any angle in this case. So the requirement is that between vertex I and J does not have to be obstacle K. And as an example, we can see how the connection between vertices looks from natural visibility graph. This is formal condition which have to be applied to connect corresponding like vertex I and J in our case. So as you can see, we do not have horizontal connection. We have connections with any angle in this case. And you can see how, as an example, this vertex 4, see other vertices like 1, 2, 3, 5, 6, 13, and so on. And here you can see natural visibility connections for exactly WTI spot prices. Definitely there are much more connections comparing to horizontal visibility graph. We can see that long-term dependence for natural visibility is much bigger comparing to horizontal visibility in this case. So this vertex, this period of time, the highest one, see almost everything in our case. And here you can see graph representation of corresponding natural visibility. So this reminds the model of preference attachment. This is more related to natural phenomena in our real world. We can conclude that definitely natural visibility much more better represents real world systems, real world time series. We can see that as an example, in horizontal visibility, we had no degree, only 10. But in the case of natural visibility, there is vertices that connect almost 180 other vertices. And for Brent crude oil, we can see almost the same picture. There is also a period of time which connects other vertices in our case. And we can see graph representation of corresponding natural visibility, almost the same picture. And as you can see in this case, we have even much more like degrees, more than 200 in our case. And this is natural visibility for Henry Hub natural gas. And again, here we have like several highest vertices. They see each other. They see other vertices that are presented to be lower. So definitely a lot of different connections, a lot of dependencies of like current time step and previous time steps. And here is exactly graph representation of natural visibility of the Henry Hub natural gas. And as you can see, there is actually, like in previous ones, we have like 2 or 3 clusters that are presented to be the most connected in our case. So now I would like to speak about exactly indicators of reversibility. In the literature, the family of visibility graphs are underrated, as visibility did not have a predefined temporal arrow. We address such directed version defining a directed horizontal visibility graph, where the degree of the node I is now split in a retarded degree and an advanced degree. The ingoing degree is defined as the number of links of node I that go from the past. So in general, we have like a degree of ith vertex is defined as the sum of those vertex that are connected to it. But if we speak about exactly directed visibility graph, in the case of like retarded or past degrees or ingoing degrees, is defined as the sum of that vertices in past of corresponding vertex. And if we speak about outgoing links, about advanced future outgoing degree, we define it as the sum of those vertices that go from that go in the past, that go in the future, that go in the future of a particular vertex. So in the case of like this particular vertex, ingoing degrees, retarded degrees will count exactly these vertices, and outgoing degrees, like advanced degrees, will count only the sum of these vertices in our case. And here you can see corresponding results for exactly horizontal visibility calculated with the Jensen-Shannon divergence. So we calculated corresponding retarded and advanced degrees. We found the probability density function for its past and future, and we calculated Jensen-Shannon divergence, or we can calculate Kullback-Leibler divergence for corresponding probability distributions. And so we can see how react our measure of complexity, our measure of reversibility on corresponding peaks, on corresponding like crashes in our WTI index, in our WTI spot prices. You can see results for natural visibility graph, how it reacts on corresponding crashes here. You can see horizontal visibility for exactly Euro Brent crude oil and natural visibility. And horizontal visibility for Henry Hub natural gas. So in general, as you can see during crash event, we have like the increase of corresponding irreversibility measure. And when our system is presented to be more stable, our measure of complexity, measure of irreversibility start to decrease in this case. And this one is for natural visibility. As you can see, much more peaks comparing to horizontal visibility, much more signals in this case. So local clustering coefficients counts the number of complete clusters that form triangles in our graph. Here, principally is the same as for node degree. So local clustering coefficient is split into ingoing local clustering coefficient and outgoing local clustering coefficient. So for a given vertex I, we can count the number of triangles that are formed in its past and that are formed in its future. So to get the measure of reversibility on this basis, we find probability density function of corresponding past and future local clustering coefficients. and find the divergence using Jensen-Shannon divergence. And here you can see corresponding results for this particular measure for exactly local cluster and coefficient, like horizontal visibility, natural visibility, horizontal visibility for Brent crude oil, natural visibility for Brent crude oil, horizontal visibility for Henry Hub natural gas, and natural visibility for the same index. And now I would like to talk about permutation reversibility. So the following method is called is based on permutation patterns. We call it permutation-based reversibility in our case. So the idea of this method is following. Suppose we have like time series X, index from 1 to n, where n is the length of corresponding time series. This time series we would like to split into subvectors with the length of d sub I and time delay between each vector tau in our case. And the idea behind each of these vectors is to define temporal order of each element in the corresponding subvector. So let's look at the presented figure. So suppose in some of your subvectors, first element is presented to be the highest. The second element is the middle one, and the last one is presented to be the lowest. So in this case, your subvectors will correspond to this pattern one. So as you can see, we have like first one, the highest, second one, the middle one, and the third one, like the lowest. And the same we can see right here. So exactly in this case, we can see at least two patterns that correspond to this one. And the idea here is to count how many patterns from the presented list are presented in our time series. So how many these patterns, this one, etc. are presented in our time series, in our dynamics. And the idea here is that if these patterns are presented to be uniformly distributed, then our series is presented to be chaotic. If only one or several motifs have the highest occurrences, the highest frequency, then our series is presented to be deterministic. But the question is how to find the irreversibility with the usage of corresponding patterns. In our case, we can quantify these patterns like in forward direction, and we can reverse our time series and quantify corresponding patterns in like time reversal, backward version. And the idea here is that if the distribution of patterns in forward version of time series and its reversed version is presented to be asymmetric, is presented to be different, then our time series, our system is presented to be irreversible. But if the probability density functions of like forward versions and backward versions are presented to be the same, are presented to be symmetric, then our system is presented to be reversible. In this case, presented to be asymmetric. And so, like previously, we use whether Kullback-Leibler divergence or Jensen-Shannon distance and calculate how our permutation patterns, how our ordinal patterns are presented to be in our time series, how reversible, how symmetric or asymmetric reversible are they presented to be. And here you can see how works this particular indicator in case of WTI index, in case of Brent crude oil, and in the case of Henry Hub natural gas. So the last measure that I would like to present is Poincaré-based reversibility. And the idea here is the following. Suppose we have like time series, the value of our returns. As an example, I've named it as G1, G2, G3, and so on. And now we want to like partition it into this arrays with two elements. We have like array with consecutive elements G1, G2. Then we like slide our window and we take G2, G3, and so on until the end of our time series. So we've got these elements. These elements will present points with corresponding coordinates G1, G2. At this point, we will have coordinate G2, G3, and so on the corresponding Poincaré plot. And the idea of Poincaré plot is the following. Here we plot dots that represents intervals of increase and decrease. And the idea here is the following. If your dots are presented to be higher than this line of identity, then you have the following relation. You have like increasing trend, upward trend in this case. So the second point in this array is presented to be higher than previous one. And if we have a lot of points above this line of identity, then we can conclude that our time series is presented to be trending in upward direction. But in the case when your dots are presented to be lower than corresponding line of identity, then you have like you have the following relations. So in this case, the second point is presented to be lower than the first one. As an example, you can see for WTI index Poincaré plot, you see how distributed corresponding points in the following plot. And you can see like these points is very densely located in this area, and there are few points that are located very distant from the presented points. What represents exactly this one point and this one? So in the case of this point, we can see on x-axis, on values of g of t, we have like almost 0 sigma. This values is presented to be in terms of sigma. So we calculated the returns and we standardized it by subtracting mean and dividing by standard deviation. And the first value is presented to be like almost 2-3 sigmas. But the second one, g of t plus tau, is presented to be higher than 80 sigma in our case. So that means that we had like very little, very unchangeable dynamics in our case. That could be described in terms of Gaussian probability distribution. But at the next time interval, the next time step, we had very, very big jump. We had a jump of 80 sigmas in our case. And we have like this point. So here again, you can see that we have for g t plus tau almost 0 sigma, like 1 sigma, 2 sigma dynamics. And then we have jump in the next step more than 80 sigma. So we had at first time step we had almost 1-2 sigma, but then we had decrease in almost 80 sigmas in this case. And in this case, for Brent and Henry Hub natural gas, you can see how distributed their points. So in this case, their dynamics in the case of Brent crude oil, we see that it's distributed in interval -5 sigmas plus 10 sigmas and so on. And we have actually, as you can see here, we has approximately symmetric distribution of these points. We have almost uniform distributed upward and downward trend in this case, and very little outliers in our case. So here we had dynamics of almost 80 sigmas, but here only -10 plus 10 in this case. And this is Poincaré plot on the Poincaré plot it described in terms of -10 sigmas plus 30 sigmas and so on. It's also presented to be symmetric. It has very rich dynamics comparing to WTI spot prices, where most of its dynamics is presented to be near to 0 sigma, so almost unchangeable in this case. And on the basis of this Poincaré plot, we can calculate Portas index, that is defined as the number of points below line of identity divided by the total number of points in Poincaré plot. So the idea of Portas index is the following: if you have very many points that are located below line of identity, then your index start to increase. And if your dynamics is presented to be mostly upward, so if there is very many points that are presented to be higher line of identity, then our index start to decrease in this case. And you can see how it behaves for particular WTI index, how it behaves for Portas index, how it behaves for Brent index, and how it behaves for Henry Hub natural gas in our case. Also, we can define Gusik's index that represents the distance of points above line of identity divided by the distance of all points in our Poincaré plot. As you can see, it's presented to be much more worse comparing to Portas index, because, as I said, as you could see, very many points distributed exactly in the range of 0 sigmas. So we have only few points that have very large distance in our case. You can see how it behaves for Brent crude oil. This dynamics is presented to be much better because we have more rich distribution of points in our Poincaré plot for Brent crude oil. And you can see how it behaves for Henry Hub natural gas. Also, we have Costas index. The idea here is that for our two-dimensional plane, for our Portas, for our diagram with the corresponding points, we define new coarse-grained series that is defined as the difference between corresponding points in our Poincaré plot. And for different value of tau, we define how these increments or decrements behave. So we find the difference between the number of points above line of identity and below line of identity in this case. And the generalized Costas index is defined as the mean value over the range of these values of tau in our case. And here you can see how it behaves for WTI, for Costas, for Brent crude oil, and for Henry Hub natural gas. This exact Costas index. Also, we can define errors index. This index represents exactly the skewness of distribution in the studied system. So if you have symmetric distribution of points, then your errors index is presented to be 0. But if the distribution of points in Poincare plot is skewed towards positive values, towards the side above line of identity, then your errors index is presented to be bigger than 0. And the opposite situation is observed for errors index when it's less than 0. So in this case, if errors index is presented to be less than 0, then we expect that our points distributed lower than our line of identity in our case. And you can see how it behaves for exactly WTI spot prices, almost unchangeable dynamics, almost straight line. So it's this index is presented to be less informative comparing to other, as you can see. We can see how it behaves for Brent crude oil. As you can see, much more forced signal like here. And you can see how it behaves for Henry Hub natural gas. So in this case, its dynamics is presented to be much more better. But again, I would say that exactly this index is presented to be much worse comparing to others. And the last two indices are related to the area of sectors. So we have a point that form this sector, and we find the fraction of sectors, cumulative sectors that are formed above line of identity to the overall area that are formed with the corresponding points in our Poincare plot. And also we can define angles of corresponding points. We have angle that is formed with this line of identity, and we have angle that is formed by this particular point. And the difference between this angle and this angle can give us slope index, and areas can give us area index in our cases. And you can see how it behaves for WTI spot prices. You can see how it behaves for Brent crude oil. And you can see how it behaves for Henry Hub natural gas. So here you can see the dynamics of slope index for WTI spot prices. You can see how it behaves for Brent crude oil. And you can see how it behaves for Henry Hub natural gas. So now I would like to present you some practical usage of development environment such as Jupyter Notebook for the irreversibility calculations. So I would like to present you how we exactly how we've got the particular results that you could see in our case. So this I would like to done with exactly Anaconda Navigator and Jupyter Notebook. But first of all, I would like to present you what is Anaconda Navigator. So Anaconda Navigator in our case, it represents exactly that different programs, different packages, like different instruments for data analysis. It has like data lore, online data analysis tool. It has IBM Watson Studio Cloud, like some cloud environment that provides tools for data analysis, data visualization. It has Jupyter Web. It's very similar to this Jupyter Notebook, but it's presented to be more extensive. It has much more instruments, but in my opinion, Jupyter Notebook is presented to be much more easier for computations. It's presented to be like a web interactive environment that has very many advantages. But if you want, you can also use Jupyter Lab for your purposes. Also, it has like Qt console. It's a GUI that supports inline figures. It supports editing. It supports different highlighting, graphical code tips, and so on. So if you have if you want to make fast computations, if you want to make fast figures, you can use this one. Also, there is Spider. That's a scientific Python development environment. It has advanced editing. It has very useful debugging instruments. Also, you can see like Visual Studio Code, very popular environment for programming not only in Python but in C++, in JavaScript, in very many programming languages. And also you can see like GlueVis. That's also instrument for data visualization, data analysis. Orange 3, PyCharm, IDE, and RStudio. RStudio is devoted for programming with exactly R programming language. So the advantage of Anaconda Navigator comparing to other environments is that, first of all, it has like tools for updating your packages. So when you work with particular programming language like Python or C++, you're working with some frameworks for plotting, for different calculations, and so on. And just by typing on a particular package, I can update it very easily. So Anaconda has its own distribution environment that provides the newest packages for your work in this case. And I can update my packages without using console environment. I can do it here just by typing like update index. Also, the advantage of Anaconda Navigator is that we can create several environments. Several particular environments for programming with different versions of Python, with different versions of one or another package. So suppose like you have Python 3.8 and you have program that works with Python 3.6. Definitely you cannot install them both in your computer. You need to have just one version of Python programming language. But with the usage of Anaconda Navigator, you can create like in one click, you can create separated environment that will support separately Python 3.10 and separately Python 3.6. Or you can have like a third environment that will support like Python 3.8 in our case. And you can switch between different environments and work with them if you have several programs that supports different versions of Python, that supports different versions of one or particular package that you've installed previously. So also Anaconda Navigator has very extensive documentation for Python, for Anaconda, for its frameworks, for Python frameworks like Pandas, NumPy, SciPy, Matplotlib, all packages that are devoted for data visualization, for some computations, for scientific computations, for like scientific plotting, etc. And here is documentation for PyCharm, for Visual Studio Code, for Spider, for different integrated development environments. Also, Anaconda has extensive community, extensive forum when you can discuss one or another question. It already has like a Stack Overflow link devoted to Python. It also has like NumPy, SciPy, main list, main answers and questions, and different blocks. So documentation, blocks for Anaconda, for Python, and for different environments that are pre-installed in this graphical user interface. In this session, I would like to present you exactly how to work with Jupyter Notebook, how to make computations of irreversibility measures with the usage of exactly this Jupyter Notebook environment. So at first, we type launch, and we have this window. This window contains your folders, your IPython notebooks. The format of Jupyter Notebook is IPyNB in our case. So different folders, different TXT files in my case, and different notebooks for calculating different measures. Today I would like to present you exactly irreversibility measures. So exactly the advantage of Jupyter Notebook comparing to other development environments is that it has is that we can split our code into different blocks. So instead of launching the whole code, the whole program, I can do it separately. I can separately import necessary libraries. I can separately set up parameters for my graphics. I can separately define my functions for calculating corresponding measures of complexity, etc. And separately, I can do getting data from my TXT files from other resources. I can separately set up parameters for the studied series. And separately, I can do different computations, different plottings, etc. So let me start with plotting necessary libraries. In the case of reversibility measures, I had NumPy framework for exactly working with matrices. I worked with scikit-learn package for preprocessing my time series, for normalizing it between 0 and 1 to make corresponding indicators comparable with our indices, WTI, Henry Hub, natural gas, etc. We have matplotlib package for plotting graphics. Here we also have pandas package. This is devoted to working with pandas data frame that are useful for data preprocessing, data normalization, data for working with data in general. Also here we have Yahoo Finance package. This package is devoted for extracting data from exactly Yahoo Finance site, from Yahoo Finance website. Also here I have one of the most important package for constructing nature visibility graph, for horizontal visibility graph. So I would like to mention that I didn't program it by myself. I just installed package and imported necessary methods for computing nature visibility graph and horizontal visibility graph. Also, we have package which is called Network X. That's for working with particular graph-based measures. Also, you can see Nemba. This package is devoted for fast computations to speed up our computations. TQDM library is created for like progress bar during calculations, and we have like SciPy functions for integrated our probability density function for estimating kernel density, for making kernel density estimation to estimate probability density function. And we have like methods or distance that gives us the possibility to calculate Jensen-Shannon divergence and Kullback-Weber divergence. So I like just type launch, type start, and we could see like a symbol of asterisk that was that means that our package is like importing, our this block is launching, and now I have like one. That means that the order of my launching, the order of my start. Now I would like to set up my parameters for graphics. Here we use like classic style from matplotlib package. We set up line width. We set up face color for axis for figure. We set up font size, which font family to use, how detailed should be presented our figures, and we like set up X label in our case. I again like type launch, and I set it up my parameters. And as you can see, I didn't start my calculations. I only set up my parameters. And if I want, I may like add another block. I may start like another programming, and I can like launch my code separately from other blocks. So now I would like to define separately functions for constructing corresponding graphs. Here you can see like function for defining recurrence net or recurrence graph. I didn't show it in my presentation, but you should remember that this possibility we also have. So not only like visibility graph, horizontal visibility graph, but we can use methods on the basis of recurrence quantification analysis. So I launch it, and so now I define function for calculating the Costas index. Previously, I presented that Costas index is defined as the difference of the number of points, like the number of increments in our series and the number of decrements in our series. That is function responsible for exactly computation of this particular index in our case. Now I define function for calculating permutation and graph-based measures of the measures of reversibility. This function is devoted to permutation reversibility, and we have two options. We can like calculate permutation reversibility using Kullback-Weber divergence. I will return to the beginning. So Kullback-Weber divergence is presented according to the following formula, and we can have like Jensen-Shannon distance. I didn't program it by myself. I just used corresponding function distance from SciPy spatial package in this case. And I can have like a graph reversibility in our case. So as you can see, I calculate graph reversibility whether for classical visibility graph, nature visibility graph, or horizontal visibility graph. Or there is third option for a recurrence graph in my case. Then we like define adjacency matrix of corresponding nature visibility or horizontal visibility or recurrence net, and then we like calculate retarded degree and advanced degree according to the corresponding function on the basis of this adjacency matrix. And also, on the basis of retarded degrees and advanced degrees, we calculate local clustering coefficient in our case. So then, on the basis of corresponding quantities, of corresponding degrees and clustering coefficients, we define we use kernel density estimator to find probability density functions of corresponding quantities. We define ranges of a particular probability density functions, and for Kullback-Leibler divergence, we find corresponding formula of Kullback-Leibler divergence, and then we make integration. So this function quad I use from SciPy package to make integration from the range A degree to B degree over the corresponding Kullback-Leibler divergence function. Or I have the possibility to calculate it for Jensen-Shannon distance. So the procedure a little bit different, but the result precisely the same has to be. Here is presented functions for calculating exactly the degree, like retarded degree, advanced degree. This loop is responsible for calculating exactly the retarded degree of a particular node I, and this loop is responsible for calculating advanced degrees in our case. And we have like a function for calculating local clustering coefficient on the basis of retarded degrees and advanced degrees. So this loop is responsible for calculating exactly retarded local clustering coefficients. We count like the number of triangles in corresponding paths for a particular node I, and we count the number of triangles in the future of corresponding node I. And then we return like retarded clustering coefficient and advanced clustering coefficient. So we like launch it, and now we have like several options. Our first option in this Jupyter notebook is to get data from Yahoo Finance. So I can like type the index of a particular index, of Dow Jones or SP 500 or Hang Seng, etc. And this library allows me to do it without like downloading CSV file, converting it to Excel, and extracting a TXT file from it. I can do it just by this method, which is called download from exactly this Yahoo Finance package. Or I have another possibility. I can get data from exactly TXT files, which I've done for my presentation. So I like downloaded Henry Hub index from some source. And so here I just can read this array of points with the particular blocks. So as you can see, each block I need to run separately, but if I have some additional code, if I want to add some additional code, I just like type plus and type here something. And if this block is presented to be useless for me, I can like type on this symbol and delete the corresponding block. So I launch these blocks, and now I plot the studied series in my that I've read it previously. This one and this one. So as you can see, we have here two graphics, two plots. The first one is devoted to our calculations. So the first one we use for our calculations, and the second one we can use for like a comparison. So exactly this one can be like initial time series, or it can be our I don't know, probably normalized returns, or it can be standardized initial time series, or it can be differenced time series, etc. So now I'm setting up the parameters of the studied series. Here you can see the size of corresponding sliding window approach. This one I described like here. I presented the example on window size of 5 days and type step of 1 day. But for my calculations, I used the window size of 500 days. So particular measure we calculated for 500 days, and the time separation between each window was 5 days. Let me make it larger for more fast computations in our case, like to type window size of 250 days and type separation between them probably even 10 days. Now I define returns type. As you can see, we have the possibilities to define initial time series or the trended one, or standard returns, or standardized returns, or absolute values, or standardized time series. These ones I presented here. So initial, difference, returns, all the possibilities can be set it up for this variable. Here we define parameters for recurrence graph, but I'm not going to present a recurrence graph in my presentation right now. I would like to present exactly a natural visibility graph and horizontal visibility graph. So these parameters serve for measures of reversibility. We have like embedding dimension that I described. Give me a second. That I described right here. So we have like embedding dimension and time separation, embedding delay tau that we set up here. I've set it up embedding dimension like 4 and tau between them like 15. We can set up like as an example 5 points. And here we define which distance we would like to use. So previously in presentation I used like Jensen-Shannon divergence, but the possibility here is also use Kullback-Weber divergence in our case. And this variable is responsible for the type of our graph. So we can use like classical or natural visibility graph, we can use horizontal visibility graph, or we can use like recurrent graph. And here is presented parameters for measures of asymmetry. Tau asymmetry is responsible for, give me a second, I will show you. So tau asymmetry is responsible for this parameter. We can like compare the difference between a particular point at time t and at time t plus tau. I've used tau equals to 1, so I compare like, I define intervals for which g of t is less than g of t plus 1, and where g of t is bigger than g of t plus 1 in our case. And this one, tau costa begin and tau costa end, responsible for this particular multi-scale measure. So as you can see, tau equals to 1 and L max in our case equals to 10 in this case. And with the usage of NumPy package, we define range from, we define the array from 1 to 10 in our case. So let me launch it with this button. And now we go to our calculations. So first of all, we've defined returns type in our case. Let me define calculations for exactly standardized returns in our case. So I relaunch it and I start my calculations. So as you can see, at first I copy my array, I copy my time series to this particular variable for plant So I copy this particular variable to save it from modifications. Exactly. And for different possibilities, for different returns type, I have like different calculations. For returns type equals to 2, I find like I find difference series in correspondence to this particular function. Let me even like make it closer. For returns equals to 2, I have this type of series. For returns equals to 3, I use percentage change function from pandas package to calculate returns. For returns equals to 4, I can find returns and then standardize it. So like subtract mean and divide it by standard deviation in our case. For returns equals to 5, I can find absolute values of corresponding returns, so I can find volatility in our case. And for returns equals to 6, I can find standardized time series in our case. So let me launch it. Okay, and let me plot it for you. So here is presented exactly function for plotting Poincare plot. We define the figure size. In our case, we can make it a little bit lower. And we can define like using function from matplotlib, which is called scatter plot, we can plot corresponding points. In this, so we can plot this particular Poincare diagram. We can define limits for this line of identity, and we can set up like X label, Y label, X limits, Y limits. We can define font size for our Y ticks, X ticks, and so on. And this function is responsible for saving our figures. So I like plot my figure here, and I save this figure for further presentations. And we can see how it looks actually. So now we would like to define arrays for further computations. In our case, that's Portas index, Guzik's index, slope index, area index, errors index, and Costas index. At first, that's presented to be empty arrays, but now we are filling it with the usage of sliding window algorithm. So the idea here is that we do it in a loop. We like subtract, take particular subseries in the range from I to I plus window, where window is responsible for window size. And as you can see, I defined it as like 250 points. So as an example, we will start from I equals to 0. We will have subseries that is indexed from 0 to 0 plus 250. So we extract first 250 points. Then we shift our subseries like by 1 day. And then we start from like I equals to 1 to 1 plus 250 points. So we have like from 1 to 251 points in our case. And then we make corresponding computations depending on the returns type that we've defined previously. Then we like drop null values. Pandas package allows us to do, as you can see, like to find difference series, to find percentage change, to find mean, standard deviation, absolute values, and so on, and even drop null values from our computations if we have such null values. Then we define like temporal fragment that is responsible to exactly Poincare diagram in our case. and we define corresponding variables for calculating like Guzik index, Portas index, area index, errors index, etc. And in this loop, in this sliding window, we append calculated results to our empty array, and we get like array of points that we then plot in comparison with the corresponding index of like WTI spot prices or Henry Hub natural gas or Brent crude oil. So let me start it. And I have like some error in my code. I'm sorry. Just let me change it a little bit. I in range. So it ended my computations. We can see corresponding results. So as you can see, I have block to separately save my txt files, separately save Portas index, Guzik index, slopes index, area index, errors index, etc. And after it, I may use corresponding txt files to plot these results in like MATLAB programming language, in Excel probably, or I can use different data visualization tools to look like to analyze corresponding txt files, to analyze corresponding results that I've saved. And then using like NumPy package, I reshaping it, and using SciPy package, I normalize it between zeros and ones. So I saved it, I normalized it, and now I can plot my Portas index that looks in such a way. I can plot Guzik index, I can plot slope index, I can plot area index, I can plot errors index, and I can plot Portas index. Now I can construct the graph of a study time series. So index begin and index end. This index is responsible for the range of corresponding graph. I subtract the first day, the number of first day, and the number of last day for a particular graph. So I defined for which subperiod, for which time series I would like to construct particular graph. So that means I don't construct graph for the whole time series, as you could see previously. I construct corresponding graphs only for a period, for a particular period of time. Like I can define a range from 500 points to 600 points. So in summary, I have only 1,000 points. Or I can define the range from like 1,000 to 1,500 days to 2,500 days in this case. So let me try to use another range, like I will start from 2,500 days and I will end with like 3,000 points. And here you can see I can build a graph for like returns type for initial time series or for difference time series or for volatilities, etc. And for a particular graph, for a natural or for horizontal or for reference plot, I like build corresponding natural visibility or reference visibility. I remember node positions and I convert it to network X representation to construct my graph with the usage of this network X package in our case. So I defined it, and now I plot the visibility connections in my graph. So this is how it looks for returns. So as I said, in this case we use like we use exactly these standardized returns, but we may use another type of a graph in our case. And we can plot corresponding graph. So as you can see, I use network X method, which is called Spring Layout, for constructing corresponding graph. Here I define like distances between each of the presented vertices. I define how many connections has one or another vertex. And here is presented functions for plotting edges, plotting nodes, for like plotting colors, normalizing all of the presented vertices, and so on. If I want, I may try to like change returns type. So instead, time series type. So instead, like of calculating it for, sorry, let me find it. Calculating it for standardized returns, I can calculate it as an example for initial time series, which I did previously in my presentation. So I again like define parameters and I'm plotting it. And you can see how looks like visibility connection for this particular graph in our case from 2,500 days to 3,000 days in our case. And I may try to like estimate as an example volatility in our case. So let me try volatility, which is the number of 5. And let me present how it looks for volatilities in our case. So that's how it looks for exactly volatilities in our case. We may try as an example difference time series. Let me set up it. Difference time series. And again, I return to constructing the graph for the study time series. And you can see how it looks for the trended time series. And we may want to plot the graph of corresponding to the trended time series. That's how it looks. So I probably will return to exactly to my returns, like the number 4. So in this case, I can again plot it. Okay, I can plot the graph of corresponding returns, and you can see how it looks in for this classical, for this natural visibility graph. Now I would like to construct the measures of reversibility using permutation-based methods and graph-based indicators. So again, as previously for Poincare-based indicators, I define like arrays for degree, for clustering coefficient, and for permutation patterns. I again start my sliding window approach. So I subtract subseries, and for this subseries, I calculate one of the corresponding time series. I make time series like difference, or I calculate percentage change. I calculate standardized returns. I may calculate volatilities, or like standardized initial time series. And then I call corresponding functions for graph reversibility and permutation reversibility. Let me launch it. Okay, this also needs to be fixed. Range. Okay, there is probably some error. Let me fix it. Okay, so just give me a second. Let's try to restart it. If I have some problem and probably I've changed my code, I may want to just restart my kernel, my Python kernel, which I use for programming in Jupyter notebook. Except Python kernel, I may have here Julia kernel or R kernel or C++ kernel for programming in C++ or programming in R using exactly Jupyter notebook environment. So I again can define corresponding parameters, corresponding time series, and I go to calculations of corresponding reversibility measures based on degree, clustering coefficient, and permutation patterns. Name ordinal distribution is not defined. In my case, probably there is some error. Just give me a second. Permutation reversibility, ordinal patterns, perm irrever, probably in this case. So perm irrever. Okay, probably there haven't been other errors. Okay, probably there is some bug in my code as I see, but as I launched it previous time, it was okay actually. So probably I missed something in my case. Graph reversibility. So it should be okay actually. As I remember, it should be okay because there haven't to be other problems in this case. Now it still has some function that's not defined. Okay, permutation reversibility. Probably I need to comment this one, and I can repeat name pattern is not defined. Okay, I understand my mistake. From ordinal patterns. Okay, I just need to find the necessary package. Yes, I forgot to add this one package, which is called ordpy for calculating corresponding ordinal patterns. Now I have the possibility to calculate my measures of reversibility correctly in this case. So as you can see, it's already done. I saved my results into txt files. I'm scaling it. I'm getting corresponding results. And I can plot that's degree reversibility, that's clustering reversibility, and that's our permutation reversibility for our exactly normalized returns. As an example, you could see how we can calculate corresponding measures of reversibility for our energy-related markets. But as an example, we can use Yahoo Finance package to download data from Yahoo Finance, and we may download particular symbol like a particular index like Dow Jones or SP 500 and so on. So let me change it a little bit. So I've downloaded Dow Jones Industrial Average Index from Yahoo Finance in few lines of code, and now I can plot it. And as you can see, exactly Dow Jones from somewhere 1994, probably 1995 to 200, 2022 in our case. I again can set up parameters for calculating measures of reversibility. As an example, let our window size will be 500 days and time step 25 days. And let me calculate it for standardized returns in this case. I may use like classical visibility graph, horizontal visibility graph. In our case, I will use exactly this classical visibility graph. So I calculate Poincaré diagram for Dow Jones Industrial Average. You can see how distributed its returns in this diagram. I can calculate corresponding Portas index, Costas index, etc. for Dow Jones. I'm saving results, normalizing it between zeros and ones, and plotting my results for exactly Dow Jones Industrial Average, plotting results of exactly Gusik's index, slopes index, area index, Ehlers index, and Costas index. I may try to calculate the graph of a particular returns. You can see how it looks for exactly returns. We may try as an example initial time series in our case. So I just change return type. I return to my visibility block, for my graph block. I recalculate it and get the following result in our case. And I can plot the corresponding graph representation of these visibility connections. And you can see how it looks for exactly this period of time, from October 2001 to January 2004 in our case. We can construct measures of reversibility for permutation patterns, for graph-based indicators, and so on. And here you can see how it looks for exactly Dow Jones Industrial Average Index. So, yeah, as you can see, in general, we can use this Jupyter notebook not only for our TXT files for our energy-related markets, but also we can download particular stock index or probably cryptocurrency index like Bitcoin USD, download it, replot it, and as you can see, we have the plot of corresponding Bitcoin from 2015 to 2022, and we can again estimate measures of reversibility even for this index. Let me set up 100 days window size and time step of 5 days and do it for standardized returns. You can see how looks exactly Poincaré diagram for Bitcoin time series, and let me calculate corresponding measures of reversibility for Bitcoin time series. So you can see how looks Portas index for Bitcoin, how looks Kuzix index, slope index, area index, Costas index, and that's all. And we actually can calculate the corresponding graph. Okay. As you can see, we have two little points in the presented Bitcoin time series, only approximately 2,000 points. So I need to change range from, as an example, 300 days to 500 days, as an example. That's visibility graph representation for Bitcoin in the range from like July 2015 to February 2016. And now let me plot a graph. Okay, we may try to build a graph for exactly initial time series. So we go to block setting the parameters of the studied series. And actually here, we can repeat our calculations. This is visibility connection for initial time series. And that is the graph representation for this particular period of time. And now we can calculate reversibility measures related to permutation patterns and graph-based measures. I'm scaling this all. I get the following results. I get the following clustering irreversibility, and I get this permutation irreversibility. As you can see, for critical events, our reversibility becomes very high. Here, like here, for this period of time, and for this period of time. So, in general, you could see how we can use Jupyter Notebook for calculating corresponding measures of reversibility for energy-related markets, and even for like stock indices and crypto indices in our case. So now, if to make conclusions, definitely energy-related markets are presented to be highly complex, highly irreversible, highly asymmetrical. Definitely Anaconda Navigator and Jupyter Notebook, perspective tools for data analysis and for different computations, for very convenient computations for debugging. And as you can see, we have like very many different instruments for measuring irreversibility, for measuring complexity, how periodic, how chaotic is presented to be a studied period of time. But except like the presented measures of reversibility, we have much more interesting indicators like for measuring chaotic behavior. We can use Lyapunov exponents, we can use different types of information entropy, and we may use fractal indicators like Hart's exponent. We may use generalized Hart's exponent and other interesting measures. So in general, if you want to download this particular Jupyter Notebook to test it by yourself, you can go to the following link. Here is presented exactly this reversibility Jupyter Notebook, but also we may see like measures, entropic measures, multifractal measures, measures that are related to recurrence quantification analysis, and so on. So if you look at, as an example, entropy Jupyter notebook, you will see like the same blocks for plotting, for measuring different types of entropy. We may see like notebook for multifractal analysis, for just standard fractal analysis. Like again, we define different fractal exponents. In our case, we can define multifractal spectrum, different multifractal characteristics, and that's all we can do, as I said, by taking data from Yahoo Finance or by taking data from your TXT file. So actually, if you want, you may test it. I will send this link right here. Probably I will add this presentation to my GitHub page, and you probably would like to refresh all corresponding figures to revisit all the presented results. So in general, if you have any questions about like code, about further cooperation, further research, you may contact me by the corresponding email, or you may contact my supervisor, Solovyev Vladimir Nikolaevich. It would be a pleasure for us to help you with the particular measures of complexity. So I think that's all. Thank you for your attention. If you have any questions, you may ask it right now or probably later. Glory to Ukraine. Slava Ukraini.
Thank you, Mr. Belinsky. We already have a question in messages from Alina Yakimchuk. Dear Mr. Andriy, your presentation is very interesting. I have a practical question. From which country it is better to supply gas and oil to Ukraine, where it would be the lower price? Thank you.
Thank you, dear Alina. Actually, to be honest, I'm not very good expert in oil and gas markets, so I cannot recommend exactly which supply of gas and oil to Ukraine will be better from which country. I think in future we probably we will need in some way to trade with Russia, to somewhat in some way to speak with Russia country, but without Putin, definitely, because it's one of the biggest suppliers of oil, suppliers of gas, probably from Arabic countries, but in this case, if you want to supply oil gas from those countries, we will need to construct new chains of transition, but definitely it will take a lot of time in our case during this war. But definitely in future, without Putin, without current government in Kremlin, I think the most suitable for us country will be exactly Russia in this case.
Thank you, Mr. Belinsky. Does anyone have any more questions?
I have questions. Thank you for your impressive report and presentation. I have two questions. First, what is the practical use of considered methods on the example of Ukraine? Do you plan to make calculations according to the considered methods on the example of our country? And a second question is, it is possible to calculate what is the allowable share of energy-related market in economy, especially of our country? Thank you.
Thank you, Mariana, for your questions. I will start with the first one. So in future, right now we develop under the contract with the Ministry of Education and Science of Ukraine, we developed the system for monitoring and forecasting crisis events in complex systems, in particular in financial systems. And definitely this research is devoted mostly to Ukraine. But definitely I wouldn't say that we are limited with a particular country in our case. So with the usage of reversibility measures, with the usage of entropic measures, with the usage of chaotic measures, we study different time series, not only financial, but of different complexity, of different nature, different physical systems like hard dynamics, or probably stress strain of during the destruction of metals, and so on. So these particular measures are suitable not only for like oil and gas time series, but as you could see for Bitcoin time series, for United States stock indices, for Chinese stock indices. So we are not limited with the country, and we are planning to do it not only for Ukraine, but for other countries, definitely. And could you repeat, please, your second question, because I forgot.
Yes. In your opinion, it is possible to calculate what is the allowable share of energy-related market in economy? Maybe some critical limit of this energy-related market in economy of country?
To be honest, I don't know, actually. So with the usage of the presented measures, I actually don't know. I know that with the usage of presented measures of reversibility, of complexity, we can track like periods of predictability, of chaos, and we know the limits when exactly to start, how long should be our trading, when to start our trading, when to stop our trading, in such manner. So our measures can be used exactly to track these periods of stability, of curiosity in crypto markets, in energy-related markets, in stock markets, in forex markets, etc., in different systems.
Thank you. Good luck in your research. Thank you.
Thank you very much.
Thank you. Is there any more questions? No. Okay. Mr. Belinsky, thank you very much for your brilliant presentation.
Thank you for your attention.
Thank you for very deep research, and I wish you success in this project, and I believe it would be beneficial for our country. Thank you.
Thank you.
Now I would like to give floor back to organizer of the conference, Inessa Hostina. Welcome, Inessa.
Today is the end of the last day of our conference. I would like to thank Mr. Zeki Kilic and Mr. Andrei Belinsky and all participants for joint work and interesting, highly effective and productive event, successful combination of theoretical and practical part of the training. The official part of the conference is over, but scientific and program committees will continue to work. Thank you, everyone. Glory to Ukraine. І я перейду на українську мову. Офіційна частина конференції наша завершено. Але попереду продовжується робота програмного комітету і продовжується робота наукового комітету. Статті ще мають пройти подвійне рецензування і пройти на плагіат. На базі конференції, наукових статей і, відповідно, тренінгу, який сьогодні відбувся двома спікерами, буде сформована програма, і навіть програма сформована, буде вам розіслана на вашу почту через кореспондента, якого ви вказували із одного із авторів статей, і у вас буде підвищення стажування, це буде безкоштовно. Всі інструкції у вас будуть на електронній пошті. Тому ще раз я вам хочу подякувати за плідну роботу, за участь, за інтерес до конференції, і роботи ще продовжуються. Слава Україні! На сьогодні роботу завершуємо конференцію.
Дуже дякую. Приємно всі. Вітання від Львівської політехніки, наших учасників дуже багато, цікаві теми. Так що велика похвала всім організаторам, голові організаційного комітету і закордонним нашим партнерам, вченим, від яких ми маємо можливість багато що повчитися в такі складні часи розбудови української економіки повністю на новій інноваційній основі. Дуже вам дякую. Вітання від всіх працівників кафедри маркетингу логістики.
Дякую вам за теплі слова.
Дякуємо.
Дякуємо.
На цьому конференцію завершуємо.
Дякуємо.
Дуже дякуємо вам.
До побачення.
До побачення, дякую.
До побачення.
Всього доброго. До побачення.